Hello friends, welcome to Independent Learning. My name is Raj Shah, and in this video we are going to start with a new chapter which is quadrilateral. Okay, so let us understand what is quadrilateral. Okay, so in the previous video we have seen chapters like parallel lines and triangles. Okay, so here we will study about quadrilaterals. So quadrilateral, as you know, as the name suggests, four. Quad means four because we have already done triangles, which means three angles. Yes or no? So here, this is quadrilateral, which says four-sided figure. Okay. So quadrilateral is a four-sided figure and it exists on a plane. So any shape which is four-sided and which is on the plane is called quadrilateral. Okay, like for example, you can say, first example, parallelogram. You might have heard about this. What is parallelogram? Then what is square? Then rectangle. So these are what? These are examples of quadrilateral. Like if you see rectangle, rectangle is a four-sided figure. Yes or no? So this rectangle is also called quadrilateral. So you can think of this that quadrilateral is the name of the parent, okay, and these are the children of the parent quadrilateral. Okay, so you can understand from that. So there are more quadrilateral, which is rhombus, trapezium, okay. So these are the quadrilaterals types. There are more, which is kite also. So here in this chapter we'll be learning about their properties, the theorems, okay, of each of the quadrilateral. Okay, so in this video we will be learning about parallelogram. Okay, like what is parallelogram, and we'll be looking at the statement of theorems. Okay, and based on those theorems we'll be understanding what is the theorem all about and how can you represent it in form of parallelogram. Okay, so we'll discuss what is parallelogram and we'll also see some questions. Okay, so let's get started. So here let us understand what is the parallelogram. Okay, the type of, okay, one of the quadrilateral. Okay, so we'll be understanding what is parallelogram. So as the word, as the name suggests, that parallelogram, that means their sides will be parallel. Okay, so here when you call a quadrilateral, okay, a parallelogram, we say that their opposite sides will be parallel. So we can write here that AB is parallel to CD. Okay, this is parallel to this and AD is parallel to BC. Okay, so such a quadrilateral is called a parallelogram. Okay, so I hope you have understood what is parallelogram. Okay, now based on this, based on, so there are theorems on parallelograms which we'll be doing about. Okay, the proofs of this we'll be doing it in the next video. So in the next video we'll be taking proofs on parallelograms. All the theorems will be taken in one single video itself. Okay, so in this video we'll be understanding the two theorems and we'll be solving questions based on this. Okay, so this is what parallelogram is. Now let's understand what is the theorem, which says that opposite sides and opposite angles of a parallelogram are congruent. That means if this is a parallelogram, okay, which says that ABCD opposite sides are parallel, then if there is a parallelogram, it says opposite sides and angles are what? Congruent. So I've written it congruent like this. So we can say, therefore, for this parallelogram, we can say that the sides, which is AD, is congruent to BC. Correct? Their sides are congruent, and this will also be congruent. So AB is congruent to CD. Correct? So the opposite sides are congruent as well as opposite angles also. So we'll say angle A is congruent to angle C and angle B is congruent to angle D. Okay, so I hope you have understood this. The first theorem, this is what it says. Okay, and the second theorem, which says that diagonals of a parallelogram bisect each other. That means let's draw the diagonals for these two. I mean for this parallelogram. Okay, so this okay, so this is what the diagonal is, the two diagonals. Okay, and the point of intersection is O. Then what does this theorem say? Diagonals of a parallelogram bisect each other. That means this point, it divides the diagonal into equal parts. So that means OA is equal to CO, AO is equal to CO, and DO is equal to DO. You know what is the meaning of bisecting? Yes or no? Dividing into equal parts. So this theorem says that diagonals, okay, the two diagonals, they divide each other into equal parts. So this diagonal AC is getting divided by BD into AO and CO, and they are equal also. Okay, because bisecting means they are divided into equal parts. So we are saying that AO and CO, they are congruent. Same way, same for this also. BD is the diagonal, it is getting divided by AC. Therefore, BO is equal to DO. Okay, so these are the conditions for parallelogram. Okay, so if we are able to, so whenever there is a parallelogram given, we can apply these rules, okay, on that, saying that the sides, opposite sides are parallel, okay, opposite sides, then opposite sides are congruent, then opposite angles are also congruent. See, opposite angles, you know what is opposite? This angle B and angle D, that is opposite. A and B, they are not opposite, they are adjacent to each other. So that is a difference. So A and C, they are also opposite. Okay, so opposite angles are congruent. Then the diagonals are bisect. The diagonals bisect each other. That means that parts of diagonals, they are congruent. Yes or no? So this. Okay. So I hope you have understood this. So this is what we learned from the theorem. Okay. Now the proof for this, you'll be learning it in the next video all together for the proofs on each and every theorem on parallelogram. Okay. So let us see some questions based on these rules. Okay. So here we'll take some questions. Okay. So I hope you have already understood the theorems. Okay. From the theorems we had understood some rules. Okay. So you have to keep that rules in mind. Okay. And then only you can solve the questions. Okay. So here is the first question, which says that, so this is the quadrilateral given to you. We have to find the length of the remaining sides, which is this side and this side, and also the measure of remaining angles. Okay, that's what we need to find. So let's see how we do. So here, okay, so PS, already PS is given as 5.3 and PQ is 3.5, correct? Now you already know that if this is a parallelogram, okay, this PQRS, this is a parallelogram. Okay, so PQRS, quadrilateral, is a parallelogram. It's given in the question itself. I've forgotten it to write. Okay, so here, if this is a parallelogram, then we have to find the remaining sides and angles. So if this is a parallelogram, we can say that opposite sides, they are congruent. Therefore, we can say PS is congruent to QR. Easy. Then we can say PQ is congruent to SR. What will be the reason for both of them? We can say the reason as opposite sides are congruent. Okay, Opposite sides of parallelogram are congruent, so we can write that reason. Opposite sides of a parallelogram are congruent. Okay, so you can write the theorem which you are using. Opposite sides of parallelogram are congruent. Then can we find QR? Then what is QR from here? It's equal to PS. PS is 5.3, so this will also be 5.3. Then what about SR? SR is same as PQ and PQ is 3.5. Therefore, this will be 3.5. Yes or no? So we have found the remaining two sides. Now let's find angles. Okay. So here angle Q is given as 50 degree. Okay. Now can we find angle S? So with the help of this angle, we can say that angle S is also 50 degree. Why? Because opposite angles of a parallelogram are congruent. So that's the theorem. Yes or no? Therefore, we can say angle Q is congruent to angle S. Yes or no? We can say the reason. Opposite angles of a parallelogram are congruent. Okay, you can write that whole statement here as the reason. Okay, therefore we can say angle S is equal to 50 degree. Yes or no? Now we don't have P or R. How do we find P or R? So here what we can do is, we already know that these two sides are parallel because it's a parallelogram. So if it's a parallelogram, we know that opposite sides are parallel also. So can we say that if PS is parallel to QR, then P plus Q is equal to 180 degree? Can I say this? Why can we say this? Because these two are forming interior angle. Yes or no? If you remember what is interior angle, there are two lines parallel and there is a transversal. So the angles inside, okay, their sum is equal to 180 degree. So we can write the reason as, so this is another question. Interior angles theorem. Okay, so this is what we get. Therefore, we can say P plus Q. So angle P we need to find. What is Q? It's given as 50. So this is 50 equal to 180. Therefore, angle P is 180 minus 50, which is equal to 130. Yes or no? Now, if you have found P, can we find R also? We can say, why can we say this? Angle P is congruent to angle R. Same reason. Opposite angles are congruent of a parallelogram. So we will write that same reason. Opposite angles are congruent. Therefore, angle R is 130. So I hope you have understood this. We have found all the three angles, the remaining angles, and the two remaining sides also. Okay. So I hope you have understood the first question. We use those rules itself. Okay. So now we'll see the second question. Okay. So here's the second question, which says that if the ratio of measures of two adjacent angles of a parallelogram is 1:2, that means if you have a parallelogram, so if this is a parallelogram ABCD, okay, and if the ratio of any two adjacent angles, okay, ratio of two adjacent angles, so here we can take AD, adjacent angles, right? So adjacent means consider one angle and consider the angle which is adjacent, meaning close to that angle. So if I consider A, angle close to A is B and D. So I have considered B. So it's up to you what you want to consider. You can consider C, then angle adjacent to C will be either B or D. So it's up to you how you find. Okay. So I have considered angle A and angle B ka ratio as 1:2, and we have to find all the angles with the help of this. Okay. So let's see how can we do it. So here, if angle A and angle B, the ratio is 1:2, can we say that angle A is equal to, so cross multiply, so you get 2 times angle A is equal to angle B. Yes or no? Correct? Now, this is a parallelogram, it is already given in the question. Okay, so can we say that A and B, they are forming interior angle? Therefore, we will say angle A plus angle B is equal to 180 degree. Okay, so you are very well know, you very well know it that this is an interior angle. If you are getting confused with what is interior angle, you can go check the chapter parallel lines, okay, where I've explained what is interior angle and also theorems on that. Okay, so angle A and angle B is 180 because interior angles test or theorem. Okay, therefore angle B is 2 angle A, therefore we'll say angle A plus 2 times angle A. Yes or no? So we'll just 2 times angle A equal to 180 degree. So I've just substituted angle B as 2 times angle A, therefore we'll get 1 times angle A plus 2 times of angle A. So it's like 1 time of something plus 2 times something, or we can say 1 times apple, matlab 1 apple plus 2 apple. So that will be giving us 3 apples. So this will give you 3 times angle A, which is equal to 180 degree. Okay, therefore angle A is equal to 180 upon 3, which is equal to 60. Okay, so I hope you have understood this. Now if we have found angle A, how can we find angle B? So angle B is equal to 2 times angle A. Yes or no? Therefore we can say this is equal to 2 times angle A is 60, so 2 into 60, which is equal to 120. So we have got A and B, which is 60 and 120. Now we can also find C and D. Yes or no? Because opposite angles are congruent. So same way A and C will be congruent. So we can say therefore angle A is congruent to angle C and B is congruent to D. Yes or no? The reason for this will be opposite angles congruent. So for both of them we can say opposite angles of a parallelogram are congruent. Okay, I'm writing this reason in short, but you are supposed to write it properly. Okay, so here angle A we have found, angle C will be, it's equal to angle A. Angle A is 60, so angle C is also 60. Same way angle D is congruent to B, and B is what, 120, so this is 120. Okay, so we have found all the 4 angles. I hope you have understood this. Now let's take a couple of more questions and we'll end this topic here. So here let's take some more questions. Okay, so here this is the given figure, and it says that both PQRS and ABCR, they both are parallelogram. Okay, and we have to find measures of all angles of ABCR. That means we have to find this, this, this and this, all 4 angles. Okay, so let's find them one by one. Now from this we can say angle P, or you can say angle SPR is equal to 110. Yes or no? Now if this angle is 110, can we say that this angle is congruent to this angle? Therefore like we can say SPR is congruent to SRQ. Yes or no? Why can we say this? Because opposite angles of a parallelogram are congruent. Yes or no? So we can say the reason for that. Opposite angles, okay, of parallelogram are congruent. So you can write that fully. Now therefore we can say SRQ is equal to 110. Correct? So SRQ is 110, so this angle is 110. Yes or no? Now can I write SRQ as ARC? Yes or no? We can also write SRQ as ARC because it is the same angle. Yes or no? It's the same angle but different name. So we'll say ARC is equal to 110, and the reason will be same angle but different name. Yes or no? So we have got ARC, which is the first angle. Now we need to find ABC, then BAC and BCR. Okay, so let's find them. Now can we say ABC is congruent? So this and this, these two angles, they are congruent. Why? Because ABCR is also a parallelogram. So therefore we can say ABC is congruent to ARC. Yes or no? Why are we saying this? Because this is a parallelogram, therefore opposite sides of parallelograms, opposite angles are congruent. So same reason, opposite angles congruent of a parallelogram. Okay. So here, therefore, angle ABC is equal to 110. Okay. So we have got the second angle of our answer. Now there are two more angles, which is A and C, which is BAC and BCR. Okay, so let's find them also. Now if this is a parallelogram, can we say that interior angles are supplementary? Yes or no? So therefore we'll say this angle plus this angle. Okay, so angle ABC plus BAR. Okay, so ABC, which is this angle, and BAR, which is this angle. So their sum is 180. Why? Because interior angles. So interior angles are supplementary. You can write that are supplementary. So supplementary means 180. So I'm writing it like that, are 180. Therefore we can say ABC is 110, so substitute, plus BAR we need to find, therefore take 110 that side, we get bar equal to 180 minus 10, this will give us 70. Yes or no? So angle BAR is 70 degree, which is this. So we have got, this is 110 because opposite angles here, then this by interior angle we have got 70. Now can we find this? If this is 70, then this will also be 70 because opposite angles of a parallelogram is congruent again. So we can say angle BAR is congruent to angle BCR. Correct? So again we can say opposite angles are congruent. So simply write that opposite angles are congruent. Therefore BCR is same as BAR, which is 70. So this will also be 70. Okay. So we have got all four angles. This is also 70. Okay. So I hope you have understood this sum. Now let's take another question, which says, so this is given to us parallelogram. Okay. So let's take the fourth question. So this says, this is the given figure, and what is given to us is ABCD is a quadrilateral, it's a parallelogram. Okay. And point E is on ray AB. So we extend AB such a way that it meets at E. Okay. Such that AB and BE, they both are congruent. Okay. So we get this. So this is given to us. Okay. what is to be proved? That line ED, so what is ED? This is ED, correct? ED bisects BC at F. That means what are we supposed to prove? That ED bisects BC, right? So we have to prove that this side, so BF, that is, we can say that is to prove BF is congruent to CF. Yes or no? Because if ED, see what is to be proved? Line ED bisects BC. This is what we need to prove. That means we have to prove that ED cuts BC into equal parts. That is equal part. That means BF and FC or CF, they both are congruent. So this is what we need to prove actually. If we are able to prove this, we can say that ED bisects BC at point F. Okay. So I hope you have understood the question, what we are supposed to prove. Okay. Now let's start with the proof. So this says, okay, so we have to prove that this and this, they should be congruent. Yes or no? So let's consider two triangles. Okay, triangle BFC and BFE. Yes or no? Let's consider these two triangles, which is this and this triangle, and we'll prove these two triangles to be congruent. Yes or no? Let's try to do it. If we are able to prove these two triangles congruent, we can say that these two, okay, these two sides, they will also be congruent by CD. So let's see that. So we'll consider in triangle DFC and triangle, so DFC and EFB. Okay, so these two triangles we have taken. Now can we say from these two triangles, can we say these two angles are congruent, vertically opposite? Because I have told you already what is vertically opposite. If you draw two lines and they are intersecting, then these two angles, they become opposite angles at a vertex, at this vertex. So these two angles will be congruent, and also these two angles, they are also congruent vertically, so at vertex opposite angles. So we can say these two angles, they are congruent. So we can say angle DOC, so DOC is congruent to angle, sorry, this is not O, DFC. So DFC is congruent to DFC is congruent to EFB. Correct? So these two angles are congruent. Now what else? What else can we take? We can say that AB, so here before writing this, we can say AB is congruent to CD. Yes or no? AB is congruent to CD. That means why? Because opposite sides are congruent. Therefore, if opposite sides, this AB and CD, they are congruent. Yes or no? AB, you can, okay, you can write this after this also. AB is congruent to CD, okay, from this, okay, and this is given already. AB is congruent to DE, that is already given. So for this, the reason is opposite sides congruent. So the proof starts here of us. Okay, so we know that OAB is congruent to CD, opposite sides of parallelogram are congruent, and also AB is congruent to BE, because that is already given to us. Therefore, from these two, can we say CD is congruent to BE? Yes or no? From these two, AB same. Therefore, CD will be same as BE. Yes or no? Therefore, this can be used in this. So we'll say CD is congruent to B. So this, let's name this as 3, or you can say equation 1. So this will be from 1. Okay, so what we have got, this and this to be congruent. So actually if you see, these two are congruent, therefore these two are also given as congruent, therefore this and this will be congruent. Okay, so I hope you have understood. Now can we say this angle and this angle? So if you see, okay, it is like this, it is forming something like this. So this is A, this is E, this is D, and this is F, and this is C. So there is this angle and this angle which is formed. See, this angle and this angle. So these two are what? Alternate angles, because this is parallel to this. Therefore we can say angle BEF. Okay. Sorry, first we are taking this triangle, right? So we'll take CDF. Yes or no? So we can say CDF is congruent to AEF. So here CDF, so which is this angle, is congruent to AEF. Or instead of AEF, we can also say BEF. So if there is a B in between. Okay. This C is here, halfway. This is how it is formed. So we can say this is congruent to BEF. Okay. So I hope you have understood how we are getting these congruents. Okay. With the help of this, you can also try to find these figures. Okay, single body, and then we can easily prove. Show the proof for this. Therefore, from this we can say, by ASA test, we can say triangle DFC is congruent to triangle EFB. Correct? By ASA test. Okay. So we have got till here. Now can we say FC and FB? They are congruent. See, FB and FC, because they are sides of congruent triangles. Therefore, this will be CS, C, T. Congruent sides of corresponding sides of congruent triangles. Okay. So I hope you have understood this. So this is how we prove. Now this is it from my side on this topic, on the two theorems. So we took those two theorems and we understood what those two theorems are. Okay, and we solved questions based on them. Now in the next video we'll be taking theorems, their proofs. Okay, the theorems on, or actually all the theorems on parallelogram. Okay, and we'll be trying to prove each and every statement which we discussed in this video, and also some more statements on parallelogram. Okay, so we'll be looking at that, the proof of it. Okay, and this is it from my side. If you have understood this video, make sure that you share it with your friends. Okay, thank you for watching.